Welcome to another GCBASIC demonstration. Thank you for dropping in. This is part 18 for the 16F legacy chips. A lot of what I'm talking about here applies to a huge swathe of the chips, apart from the AVRs. This is all like PIC. You can do what I'm showing here, not just on the legacy ones, but also on the newer chips as well. But I want to just make sure there's no differences. So I will go through that in some detail. So what we're looking at is assembly, alternative assemblers, and MPLAB-X. In the previous video in toolchains, we introduced the concept of alternative assemblers. Let's go deeper. Like and subscribe. Let the video run all the way through. You'll get the latest updates. Please do this. 18, we're nearly there. So we saw this diagram yesterday where we take, it's the operation, how it's a concept of operations, where we take your source code, we take some libraries. I think yesterday in the previous video and the previous video, we saw that we had one subroutine of 480 that were down in the library set. There's a vast amount of code. We take that, we do code translation normally, we assemble that in a thing called GCSTUDIO, we produce some files. One of them happens to be an assembly file, which you can look at, and we'll look at that today. We link it in GCSTUDIO, and then we produce a machine-specific hex file. And as we saw in the previous video, we can actually do PIC-AVR, AVR-DX, LGTs. The same source code can work right the way through because the libraries and code translator are handling it all for you. We also saw how we can take your source code and pass it through the code translator and assemble it, produce an assembly file along with the reports, pass that through a linker, and yesterday we went in the previous video we went through MPLAB-X, but we can go through an external linker to produce a hexadecimal file. And you might want to do that for a quality check, but we're going to look at using PIC-AS, PIC-AS, the horror, and MPLAB-X. And there's good reason to do that, and that good reason is you can use the simulator. So what we're going to do is something quite hard. We're going to create a program, a simple LED, just to flash the LED. We're not going to see it actually operate because we're going to see it logically. And we're just going to change the compiler to PIC-AS. And PIC-AS is the replacement that Microchip introduced in 2000 and I think when it was 2021, 2020-ish, to replace something called MPLAB-X. And GCBASIC can produce both MPLAB-X or the source code required for PIC-AS, and you can pump it straight in. Then we're going to create a project. We're going to create a standalone project, specify a chip. We're going to select the simulator. We are going to select the tool chain we want MPLAB to use. We're going to give it a name, set up some parameters, suck in our file, change the frequency, step 7. You can actually program. You can actually program from MPLAB if you wanted to. You can actually walk the code with the PICkit4. We're going to do a lot of that. I might not hook up a PICkit4 today. Just a lot of work. When I'm using a PICkit2, it's a lot of work. Let's get started. I am in the IDE. Here it is. There you go. I'm going to open up a file and I'm going to call it test. The one we used from the previous video will do me. Test. Control B to shut that down. It says here, wrong chip. I want to set it up for a 16F. And for any chip that PIC-AS supports, you can do this, by the way. 1937, that's the chip I'm using. And I said pulse it out for 100 milliseconds. Well, I'm just going to change that because that's a very specific for the 10F. Do loop. I'm going to type in a do loop. There we go. Now, if you actually indent that up, in this editor, you get to see the code. So what I mean by that is you can actually see, it's color-coded. Look, it tells you It's there. Okay, let me just, I should do it properly. Hash define port B.5 as LED. Let me have a look what it is. Oh, it's RB3, sorry. LED D3. It's on port B3. 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 LED equals 0. LED equals 1. All it's going to do is turn it on at high speed. There's no delay. And I'm only not putting the delay in so that we can just show you how it works. You can then put a whole program through this, but to put a whole program through needs you'd have a lot more as an assembler. Okay, let's just check that works. Function key F6 or just make the hex icon. Ooh, that worked. Worked in GCSM. Control J to shut that down. Open up the preferences editor. Preferences. Type in the word pref. Open it up. And we're going to change that now to PIC-AS. And that's a functional change to the output on the compiler. It will still generate what's called an ASM file, ASM file, but now it will produce a suitable file for MPLAB-X. And whilst we're waiting, I'm going to fire up MPLAB by clicking that icon there. I'm doing that now because it takes a few seconds to open. Okay. Now, here's my program, and in the back you can see MPLAB opening. That's great. Not a problem. So now, if we look in here, we've got our file. We've got an ASM file, a CDF, that's a conditional definition file, or constant definition file, call it what you like. Hex file, the HTML file. Oh, can we see that inside of the editor? Oh no, I bet I can preview it there. No, I can't. You have to open it somewhere else. Just close that. And you've got the LST file, which is the list file. And I'm not going to go into that. But now, because I've selected PIC-AS as my output, I'm going to press function key F6 to compile the file. It will pass it out to PIC-AS and it will come back, and it's extremely quick. I mean, it's done it. It's done it already. So, but look at all the files it's created, the additional files. Look, it's got an ASM file, CDF, CMF, a .d, elf, error. You can look in the error file. Is there an error file? Yeah, there's no errors. I'll fancy that. As a hex file, and that was produced by PIC-AS as a HLXL. But look, down here somewhere in here, there's a .s file. Oh, there it is. Look, assembler.s. So what you can do is you don't have to wade through all that. Control B, just press Control F4 and type in the word open, and you get two options: open.s or open ASM. Open the .s, so you can have a quick look. And here is a source file. It's a source file for MPASM, MPLAB-X, sorry. Slightly different format. If you do a compare between the two. So I'm going to just take a copy of that path there, and then we're going to go into the IDE. I'm now looking on my screen at MPLAB. I'm going to delete the program that's there because it will just confuse you and me, because we're going to create a project from scratch. So I've got no projects in the left-hand side. I'm going to resize MPLAB-X, sorry, because I've opened up MPLAB-X, and I'm going to shuffle things about to get it into our zoom window so we can see it, or I might actually move it around. Let me move it all around. It's a bit of a pain, but here we go. So first thing you need to do is create a new project. So you go File, New Project. Move the window. Microchip Embedded, and an application project. I'm using MPLAB 6.2. Next. Select the chip 1937, and it will give you a list, and it's filtered on that 1937. And then I want you to select Simulator. That's it, Simulator. We're creating a simulator program. There is no debugger header. And then you need to select the compiler. Well, select PIC-AS, and I've got lots of versions installed, but version 3 is the latest, so we'll do that one. Next. Give it a project file name, 1937. My advice at this point is to uncheck Open MCC because we're not going to be using MCC because MCC does not work on legacy chips. But set as main project is a good idea and press Finish. It will now create a project. I'm now just sliding the display about so you can see it. Source files. Click No source files. Right-hand mouse button, add an existing item. And if you remember, I took a cut and paste of that .s file, and there it is. It's this big long name here, and I can just press select. Now at the bottom of here, I'm going to shuffle this editor about, this IDE about. Lots of people are very scared of MPLAB-X. Don't be scared. Just do what I do. Just ignore it. I'm trying to get it so it zooms in for you, not me. Here we go. If you want to know what happens, look, you can go production, build it. And it's just going to do the compilation process, exactly the same compilation process that it did when it was inside of GC Code or GCBASIC's IDE. Exactly the same. It's produced all the same output files. It's done it. And now what I want you to do is go debug and select. You can debug the main program. If you've got a PICkit4, plug it in at this point. But now I want you to go. I just need to. I don't think I'm going to be able to see it on the. You can't see the whole thing, so I'm going to slide the screenshot to the right. Debug operation, build for debugging main project. It will recompile and it will generate a series of other files, in particular the ELF file, and the ELF file is required for debugging. And it's done it. It's generated a version of this hexadecimal file for debugging. Press debug, discrete debugger, launch, debugger main project. It's launching it. Oh, what's it doing now? No errors, look. Let's pull down this bar here and lower that down so we can see what it's doing. Well, this is the source program direct from GCBASIC. If you don't believe me, it says here that this file was compiled. I think it tells me the date nowadays, doesn't it? Because I did need, oh, here, in here, look. It was compiled today, the 29th of January at 1302. It's currently 1307, so that is the file. And it set the pointer at the first line of the program, page select, and it's assembler. You can walk the code by debug. You can walk the code by pressing function key F7. So it's going to go through and jump to the first major instruction, which is initialize the system. And it sets up, it's documented, look. If you have add the comments on, it's actually fully documented. So it's setting up some registers, turning off the ADCs, setting the ports to digital, turning off the comparator, and clearing out and setting up all the ports to 0. Return. GCBASIC in this case, and I was unaware of this until I've just seen this code, is decided to automatically set the pin direction for the pin that we selected in our source program as an output. Did it automatically. I'm amazed at the way the compiler does things. So it sets up the automatic pin direction for you. And now we can do something really clever because it says here, bank cell BCF, BSF. This is bit clear, that B, BSF bit set. So it's going to set it to 0 and 1 and loop around. How do we know it's doing that? Because I can come into the variables, and if I just show you, if I delete OSCON, don't need that, delete. Here's port B, and I'm just going to open that up. I'm going to pull that up a little bit, just so we can see enough of this, okay? We don't need to see all of it. We need to see bit 3 though, don't we? Because that's the one we're playing with. Come on, get up there, boy. That's a bit too far. Here we go. Function key F7 to walk in the compiler, in the debugger. Bit clear, bit set. Bit clear, bit set. Oh, there, look. Go to, select the bank. Bit to clear, so it's going to take bit 3 and clear it out. There we go. Bit set. Now, you might say, well, that's unoptimized as assembler because that bank cell's in the wrong place. Well, let me reassure you, over a very complex program, if I tried to move the bank cell before the do, I would have no guarantee that it was in the right place because the do, yeah, that's the loop needs to have the bank cell inside. It makes sense. It's logical to have it inside because if you had a call to something different in a more complex program, we're talking of one word. So we're now seeing function key F7, we're seeing the compiler in GCBASIC within MPLAB-X, and it's doing its stuff. Yes, you can do a lot more complicated debugging in here, but I'd also be using serial and I'd stay out of MPLAB-X, but you can do it. There is rationale for using this, and you can do the same with AVRs, the same with LGTs, same with newer chips as well. It's a very good capability. Let's look at exactly other parameters that you could change. You can set the frequency, and you should set the frequency in the IDE, MPLAB IDE, to the correct frequency. If you want to see it run at the right speed, make sure you do that. So let's look at that and do that. The problem is here, I've got a very small window to show you all this in, because let's zoom. Let me zoom into here. I'll pull it across to change the frequency, select the program, the project, sorry, and then at the bottom, it says properties. You can't see that, so you're going to have to trust me. On the bottom of there, it says properties. It opens up the properties, and here it is in here. And so what you should do is in the simulator, take the simulator tab and set the instructions frequency. The debugger is currently running, so I'm going to stop I'll unlock it, change that to 32 because my chip's running at 32 mega frequency. And if you wanted to have it automatically program, you would actually come into the building, execute this line after the build. And what that line is, that's the line that I showed you inside of the PowerPoint, which is this big line here, which is the command line. And it does all the substitutions for you so that you can then just press function key F5 and your old PICkit2 will work. By pressing F11, you can debug it live. Great. That's what I wanted to show you. That is assembly files, alternative assemblers, MPLAB-X works. Enjoy.